Okay, so we've talked about sample spaces, we've talked about simple and complement probability, and now we're going to talk about experimental and theoretical probability. So experimental probability is when the ratio of the number of times an event occurs to the total. So we can still write this as a fraction. We can still write number out of the number. So this would be the number of times out of the total. About what, and then what does happen. And then theoretical probability is the probability of an event happening based on the possible outcome. So what should happen. So experimental probability is what does happen, and theoretical is what should happen. So let's look at the spinner. Use the spinner below to answer the questions. Then spin the spinner 10 times and complete the table below. So number 1 says, what is the theoretical? So remember, theoretical is what should, theoretical is what should happen. Probability of spinning a section with stripes. So looking at this, we have one section with stripes out of 1, 2, 3, 4, 5, 6, 7, 8 out of 8 total sections. So the probability is 1 out of 8 or 1 out of 8. So that's what should happen. We have 1 out of 8 chance. And the theoretical probability of spinning a section with stars. So with stars, we have 1. That's not a star. 2. So we have 2 out of 8. And what happens with these ratios? They need to be simplified. So we need to divide the top and bottom by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. So we have a 1 out of 4 chance. And then what is the theoretical probability of not spinning a solid or a stripe? Not spinning a solid or a stripe. So that means that we spin anything except for solids and stripes. Well, so this is not a solid or stripe, this is not a solid or stripe, and this is not a solid or stripe. So we have a 3 out of 8 chance of spinning that. This next part wants you to now do the experimental part. So this is experimental. So those are the things that should have happened when we're doing theoretical. And then now you experiment and see, well, did we get those same ratios, or what happened when we actually did the experiment? So if you have this on paper, you're going to go ahead and use your pencil and place it in the middle of the circle on your paper and spin your pencil, and whatever you land on is what you get. So I don't have a spinner on here. So I'm going just to count to 5. So 1, 2, 3, 4, 5. I landed on a solid. So I'm going to put a tally on white. Okay, and then I'm going to erase. And I'm going to start where I landed. 1, 2, 3, 4, 5. I landed on dot. Okay, and then I'm going to do it again. 1, 2, 3, 4, 5. Ooh, I'm going to say that's closer to the solid. Okay, and it said to do it 10 times. So let's go again. 1, 2, 3, 4, 5. Stars. Okay, start the stars. 1, 2, 3, 4, 5. white again. 1, 2, 3, 4, 5 stars. 1, 2, 3, 4, 5 white. Oops. 1, 2, 3, 4, 5 white. 1, 2, 3, 4, 5 dots. 1, 2, 3, 4, 5 dots again. 5, 6, 7, 8, 9, 10. So that's 10. Okay, so total number of spins. I landed on stripes 0 times, white 5 times, dots 3 times, and stars twice. Experimental probability. So this was 0 out of 10. This was 5 out of 10, which simplifies to 1 over 2. So half the time I landed on white. My dots was 3 out of 10. And my stars was 2 out of 10. 2 out of 10, which simplifies to 1/5. Okay, so are there any results in which the theoretical and experimental probability are the same? Why or why not? So ours was really close on the, I believe it was the stars. So stars, we had 1/5 chance, which is a 20% chance. And on the theoretical probability, it was a 25% chance. So those are very close. So probably are the same. It's probably just likely or almost likely to be the same, but more likely to be close versus being the same. I think we have a better chance if we say we're going to be close to the theoretical versus being the exact as the theoretical. And of course, if you paused and you did your own spins, which is fantastic, your numbers will probably look a little different than mine, and maybe you did match up on some of them. So let's go on to the next one. Relative frequency. We're going to do this one actually on the next video. So go to video 2.